Now this tape is part of the Brodak Cardinal construction series, and on this tape we're going to have Tom Hampshire demonstrate for us one of the ways of custom tuning the K&B 40 engine. Now, since beginning the Brodak Cardinal project, we've set out some real guidelines, and we've met most of them. So far, the plane is completely finished, contest proven. It's won its first expert contest, and we have a few more criteria for it. Now, when we started the project, we wanted to start out basically that we could get everything from John Brodak. We also wanted everything to be as inexpensive and simple as possible, and I think to the almost total degree we've succeeded at that so far. Pretty much every part we've used, maybe with a few exceptions, has come right from John. The idea being we would want one-stop shopping. We also, one of the criteria we wanted to have when we built the plane is something that I call choices. Now when you have choices in life, for instance, when you have 3 choices of restaurant to go to, you pick the one that you want to go to. And what happens if you have 1 or 2 or 3 choices? You try each one once and you pick the one that you like the best and go back there as many times as you want. To me, that's called choices. Now, in the world of control line stunts, sometimes your choices are really limited. You always have the standby Fox 35 motor, but there's very few other motors that are appropriate right out of the box. We started off wanting to have one of our choices, the K&B 40 engine. Again, it was available from John. Totally stock. I did not want to get involved in some kind of a custom rework special. I have the only one, and when you go to get one, yours isn't just like mine syndrome, which plagues a lot of people. They seem frustrated by the fact that their motor doesn't run like some of the other people that have the same motor. So by using a stock motor, we were really able to push it to its limit, and I think that limit is a very practical place for most people that are in the hobby. This will suit their needs very well. With the idiosyncrasies that come along with that type of a motor, we also now, we know you can get the double star 40s. Actually, you can get the whole line of double stars from John. And we thought it would be worth pursuing this, but one of the things I want to make sure when I do this is that I'm using a stock motor. I don't want to get, at this point in time, get involved in this rework by this guy, this rework by that guy, and you get all these confusing sets of data to deal with. So right now we have those 2 choices. But the third choice, and the one we're going to deal with on this video, is we're going to do a little bit of a timing check, timing alteration, I don't know what you want to call it. Tom Hampshire has volunteered, and he does this on a regular basis. So what I thought is, we've already used the motor stock. Let's see what difference, if any, we can squeeze or get out of a motor that is reworked by Tom. But at the same time, we want to see exactly what he's doing so that it's duplicatable. I don't want to have any secrets. I want to look right down at Tom while he's doing this. I don't ever want the motor out of my sight. Now, you know, anybody that's ever had motors reworked, you know there's variations in all motors. That's perfectly normal. But when you see one that runs exactly the way you like, the best idea is just to copy it. Don't bother even trying to reinvent it. So we're going to try to get Tom over here, spend a couple hours with us, and teach us all that he knows about getting that type of motor to run as well as it can in a mildly reworked form. For anybody that doesn't really understand some of the terms, let's just make some real simple examples up here. Glad I'm not an artist. Simple Fox 35. The old standby, 2 Ford reliably, lasted practically forever, was awful to break in, usually got black and cruddy on the top, but it also had an extremely well thought out set of criteria. If you look at a Fox 35, these are some of the things that you will notice instantly. It's a light motor. Relative to some other 35s, it might even be the lightest one or one of the lightest ones. It also features a very short in length and not a replaceable venturi. A short venturi tends to make an engine brake harder and sooner. A longer venturi takes it into a range where it takes longer to change its resonance. It has a very short exhaust stack for the same reason. Short exhaust stack, short venturi, short exhaust stack, and basically running totally unrestricted exhaust. What that gives you is a tremendous, hard, reliable 2.4 brake. Very, very reliable. Very predictable. Now this is one of the engines that John Brodek has given to Ken Thompson to put in his new Nobler. We have it out sitting on the table. Notice a lot of things. It has a very small amount of finning so that it tends to run hot while it's in a 4-cycle. An engine with too much finning, too much head finning, is going to tend to run cool and want to shut off. Now, various models of these motors have various good and bad sets of muffler ears. I'm never sure which ones are which. Again, that's up to Tom. These motors need a tremendous amount of break-in before they're really seated nice. This one, you can see I'm getting all greasy, is already been broken in. It's ready to put in Ken Thompson's Nobler. But again, notice some of the things. Small amount of head fins, small amount of case fins. Relatively short, small exhaust stack. Very, very long power stroke. When I say a long power stroke, I mean from the time the piston is at top dead center to the time that the exhaust port opens. That's known as the power stroke. And on a loop scavenged motor, a motor with Fox 35 type of timing, that's very long. It's a very long part of the crankshaft rotation. It's a very significant thing. When Duke Fox designed this motor, it has an extremely small crankcase volume. When the piston comes down, everything is compacted up. The piston goes up, it pulls fuel like a vacuum cleaner. And those are the things that made the characteristics of this engine. When you make an engine for stunt, you tune for characteristics, not for total maximum power. Now, if you look at a double star 40, you'll basically see it's the same short venturi, even though this is removable. Small head fins, very light compact case, very small amount of head finning. So this motor is basically made to run at a lower RPM, to run with a long power stroke, basically at a lower RPM range than a higher high-strung motor, any motor that is Schnurly ported or ported for maximum power. Now the K&B 40 is a motor that makes a whole lot more power than a Fox 35. And one of the things, there's several ways people go about detuning. Head shims. Head shims will lower the compression. This is the most simple way to kill off horsepower on any motor, is just put an extra head gasket or two. That's one technique. Another technique is to make a smaller venturi, a longer venturi. Now that, in the early days of trying to adapt Schnurly powered engines to work in stunt, they would wind up using head shims much smaller than normal venturis. And what happens at this end, if this is taken to its max, you wind up using a small amount of fuel. And an example is when you're using a small amount of fuel, The downside of that is you're also using a small amount of oil. And when you run an engine like a 40 on 3 ounces of fuel for a stunt flight, you're really not running enough oil through the engine. And that's the problem. That's one of the problems people have encountered in trying to fine-tune or up-tune these engines to make stunt motors out of them. When they modify them, they wind up with this combination that it runs on 3.5 ounces of fuel. They don't have enough oil going through the engine or alcohol, and the motors tend to run way too hot. And to give an example of this is when you see a motor that halfway through a flight just takes off and goes dead lean. We call that the snarly two-step. And what happens to control that, there's several different ways you can control it. You could always add oil to the fuel. If you're going to run very small amounts of fuel, calculate it out. Add oil. That's one of the ways to get around it. But basically, one of the things that other people that rework motors have tried and been successful with, rather than going to that combination, they've taken the whole cylinder liner, machined a case, and dropped the liner down. In this case, probably 30 thousandths would do it. And what that does, it lowers the exhaust port. And the problem with that is a lot of times now, and I don't know that this is why we have Tom here, when the piston comes to top dead center, you get a phenomenon known as the bottom of the piston skirt doesn't close off the window, and you get sub-port induction. Now the way to get around that, of course, is to make a piston with a longer skirt. But what happens is, now you're getting into real expensive modifications, you're turning it into drag racing instead of fun. Now, we're not going to be doing any of this. What Tom is going to try to do is a technique, and I'm going to leave this part of it up to him, where he changes the porting on the engine. It doesn't take a whole lot more than a timing wheel and a Dremel tool to do this and some careful workmanship. It changes the relationship of the ports. And it's been successful. It's relatively inexpensive to do. And it's one of the things we want to have all the choices. When we go to the field with that motor, we want to have all the choices possible. And having this reworked engine, for instance, if we go to the Mass Cup and we have Midgley's got his set, we can try a stock motor, reworked motor. We can try the double star, and his father has one with a 46 Super Tiger. Well, anybody can see, within 2 planes, we have 4 motor choices. And this is what I want to wind up with, is throughout the summer, I want to have as many choices as possible as we try to get more and more data on this design, because we really feel this is a design we'd like to push the envelope out a little more, make it as competitive as it can be without turning it into drag racing. We're trying not to. You could always, of course, order up very expensive engine parts, custom-made liners, custom pistons, but to try to do this on a reasonable budget. Bill Mazzoni also has suggested some things that we're going to try, but tonight we have Tom Hampshire coming in. We're going to try to get him to show us what he knows about reworking these motors, some of the pros and cons. And a lot of times the things you do, if you can share them with people, you can keep them from either making the same mistake or falling into the same trap that you have. And basically by sharing it, we all learn from each other. And that's the fun. I think that's the essence of model aviation. I want to talk for 1 second about something that I know about motors. All motors, it doesn't matter if it's the Chevy V8 in your car, an aircraft engine, a turbine, every motor is going to have an ultimate restriction, and that's going to be something that's built into the engine either on purpose or not on purpose, that's going to be the ultimate restriction that keeps it from making more and more horsepower. Otherwise, your lawnmower would go to 3,000 RPM, 4,000, 5,000, 8,000, and the crankshaft would break. There's always a built-in restriction. In a Fox 35 or a loop scavenged motor, the ports are very small, on purpose. They're set at angles that aren't very efficient, and the gas has to work its way around a piston baffle before it goes out. So this whole system is very restrictive on purpose. When you go to take a Fox 35 type of motor and make a combat motor, the first thing you do is make the ports bigger, wider, open them sooner and leave them open longer. But all of these things, anytime you reduce the restriction to make more power, you change the characteristics. And by changing the characteristics, you then have a stunt motor that's a combat motor. What we're trying to do is go backwards. We have an engine that really doesn't have a crankcase type restriction. That engine is made to make a tremendous amount of power. And by changing the port timing, it should in essence make it a little bit friendlier, a little bit more user friendly. What we're looking to change, we're not trying to make more horsepower. We're trying to change the characteristics of the engine. This is an important concept. When you have a high output engine, an engine that makes a lot of horsepower, it does it over a narrow range. The peak looks something like that if you were to plot it on a graph. It makes a very tremendous amount of power over a very short range, and that's it. And it falls right off, and it's really terrible. You'll notice if you take some of the real high output Schnurly engines and you back out the needle, they almost shut off. Well, they fall off the power curve is what happens. Now what we're trying to do, in essence, is soften this up a bit so that it doesn't fall off the needle valve when it gets rich, and it doesn't go over lean and run away like a freight train when it goes over lean. What we're trying to do is just overall soften up and make the engine more friendly without making it a major project to do it. Now John has tried like heck through his catalog and through his dedication to the hobby, really, to really make an engine that's as user-friendly as possible for a very, very reasonable price. And in this price range, there aren't many things that are friendlier. But keep in mind, we still want to have the options. We know what this stock option is. We know, you can see on the videos, you can see the contest wins, you can see the things we've had trouble with. This is all documented, so we now enter an area that I hope is going to give us one more option. Along with the stock K&B, the stock double star, we're going to have an engine that's been reworked by Tom Hampshire. And without further ado, let's go to the video. Now one of the things we're going to be doing, we're going to be using the motor that we did all the test flying, all the development. This motor has about, I'm guessing, a rough guess would be 5 gallons of fuel through it. It's been extremely reliable. In fact, we've never even switched the glow plug over. We put a Thunderbolt in it and it pretty much stayed there. We never got to even do any glow plug testing. A couple of the things that are worth mentioning that we did get to try. This is a round muffler. It comes from Art Adamissen. You can buy this direct from John Brodak. We found this to be a little bit on the restrictive side for our purposes, and we opened up all of these holes. There's 10 holes, opened them up to 1/8 inch, and that made this very, very usable. Again, that's a personal taste thing. In a case of trying to get more and more power out of an engine, the price you pay is to open up the exhaust and get less and less restriction. Now, what we did find, and there's several little things that can save you basically some time and energy if you're setting up a K&B. Having a piece of this 1/8 inch gasket material, this was an idea from Peter Michael, between the fuel tank and the airplane, turned out to be one of the best tricks of our whole development program. And we did use this. This was a cracked tank, a spare tank. We glued it right to a piece of composite material and then made a gasket for the side, basically to use the adjustable tank mount type of tank mounting that John sells. We started off with this tank. The snub-nosed tank, in my opinion, didn't have as good of a motor run as the long thin tank, but that was these are personal choice things. We had a tongue muffler from Bill Mazzoni that we wound up plugging 5 of the holes up on and running it on muffler pressure to get it to run the best that we could get it to run on. And this is a really good starting point. These are available from Bill Mazzoni. These are the choices that you want to have when you go out to tune a K&B 40. either a stock one or a non-stock one. Again, the muffler that comes with the engine, it's a nice quiet muffler. It runs beautifully. There's only one problem, it's heavy, believe me. So in the case of the K&B is already heavier than the double star by almost 4 ounces. So we don't want to pay the penalty of having a 4-ounce muffler or 3.5-ounce muffler. So we wound up, and we were the happiest when we had this combination. I have this all written down for my own records. This combination of 15 holes on a Bill Mazzoni muffler, running on muffler pressure, with a long tank, running it on Uniflow, of course. This was our best overall combination right here. And this is the one we want to take to the bank, or use as our square one for when we go back and try to upgrade the performance. Well, we want to have a square one. We want to have something we can go back to and say, yeah, we want to make it better than. Now, if for some reason it turns out that it's not as good as, or we're not happy with it, we'll just order stock parts. These are stock, reasonably priced parts you can get right from John Brodak, and go back to our stock configuration. So we always want to have the square one. We never want to lose our little notebook with all the little notations on it of all the things we've already tested. Okay. Anybody that doesn't know, this is Tom Hampshire. He's a...
Good evening. How are you?
I don't know if he does the 5 o'clock news or just the Schnurly two-step yet. We don't know yet.
We're pretty good at dancing when the stun motors run away.
I don't know. I judged with him last Sunday. He's a load of laughs to be with, but when it came time for the pizza bill, I looked over and he wasn't there. He was strangely gone.
Didn't think that short, fat guy could move that
There
quick,
was steam
did you?
coming off the seat, and he was gone. Oh, anyway, the first step he's doing, we're trying to have fun, of course, as we always do. His first step is to try to disassemble a motor.
Yeah.
The screws on a K&B are 440 Allen screws, so it's very simple to take it apart. Usually the liner will drop right out if you turn a motor upside down.
Yeah. What you want to buy if you're at the store is a 3/32 Allen wrench. Either this or a ball driver or a T-handle is fine, but it's 3/32. That's what fits our standard 440s.
It's a no trick, no metric, not like Super Tiger where everyone is, I don't know what the threads are. They're different, I know that.
M3s.
Yeah.
Metric number 3.
Yeah, but there's some that came 540 and some came metric, so you never know. And some came, who knows, you know?
Yeah.
What was in the pepperoni that night? Now, like a lot of Japanese engines, the back comes off a K&B, the front comes off. So in theory, maybe you could even run the crankcase with the exhaust going the other way.
You'll find...
Like the older FSRs?
Not from this motor itself, this example, but from years ago, the 61, Series 61, the first gray crankcase K&B after the greenheads. You could run those. I ran them in rat race, and believe it or not, didn't make any difference which way you faced the exhaust stack. I drove myself nuts.
No gain, no loss.
I drove myself nuts trying to figure out how. Now that's a problem. Okay.
Okay.
That's
you got a little
chip.
Little aluminum chip.
A little piece. A little piece.
The only thing I don't have here that I have at the machine shop is a cleaning tank. If you need, I'll set a...
Doesn't make any difference. This is... A K&B is always... I mean, we're making chips here that were not in the engine. We're making chips that were drawn by the screw head when it came down against the backplate material.
Right, exactly.
None of this stuff is inside. K&B's manufacturing standards are very, very high.
What I found with this motor, it was absolutely as reliable as a stone. It was predictable in every way. Needle settings were dead predictable. The only comment I had, it really wanted to turn a big prop. If it had a small prop on it, it turned into a real powerhouse in a hurry. Nothing 10 inches was even close. And I wound up with an 11 and a half and 11 and a quarter, a 13-inch prop cut to 11 and a quarter, the day I had it at the contest.
Boy, isn't that pretty?
Now
Look at those. Isn't that pretty? Just as nice as you could want.
There's nothing wearing on the back here, which is a sign that something's out of misalignment.
It's not chewing up the back plate.
Gasket didn't even delaminate coming apart.
Gasket didn't come apart. Everybody is just spick and span clean in there. Machine surfaces are all nice and shiny. Isn't that pretty? All right, on to the data sheet. The first thing I wrote down was the engine weight, 9.6 ounces.
Okay, by the way,
Not a
I
bad
did
thing to have.
I did a test of my own that you can copy, you can have that information. I weighed the K&B with exactly no hardware and a double star with no hardware, and the difference is 105 grams.
Okay.
So that's a significant, I mean, a person just can't switch without somehow accounting for that.
Yes.
It's almost 4 ounces.
Yeah.
So in my case, I had the double star already in the plane, and I'm assuming I'm going to need some nose weights somewhere down the road, or I'm going to have the most violent corner on the planet.
Well, and the double star is plain bearing.
Plain bearing, low RP. We've all been through that. It's a whole different animal.
Yeah. So the double star, on the weight of the bearings alone, not the bigger crankshaft housing to support them, the double star is an ounce lighter.
Yeah, yeah.
Just if you take the bearings away.
If you take them away.
Then there's all the extra aluminum to house the bearings.
It's 3/4 of an inch longer as a second. I mean, every step of the way, it's like I'm hoping it's going to be a better plane or a different plane. And that everybody would have, number one, the choice of having a stock engine, which we can make work reasonably well. This one didn't have a real tendency to go crazy. And you can make it better. That's choice 2. The double star is choice 3. And I'll bet you that plane, if you had a real good Fox, an old-fashioned one with the square intake, you could come up with some concoction of Fox that would pull out. It's 42 ounces with the K&B, 38 ounces with the double star. But it's a thick wing. That's the whole. I don't know if Foxes, unless you run them unrestricted, if that would be an appropriate choice. Okay, let me get around and do this.
Yeah, let me get...
From this angle, a lot of people don't know what a timing wheel is. You never worked on motorcycles. This is all mumbo jumbo. I assume everybody, when they were a kid, worked on motorcycle. You never took a lawnmower apart? How did you do that?
We always did okay Cubs, but we didn't time them.
Okay, now a timing wheel has degrees of timing referenced off top dead center. Top dead center is when the piston is completely at the top of its travel. Let's see what Tom has referenced on here. I see he has it referenced in Polish, English, and Czechoslovakian.
Magic marker.
Magic marker.
And magic. But the trouble with this one is it's getting old and greasy. It's had a few gallons of castor oil, and assorted pizza goo and such.
Yeah, it's going to have more pizza goo tonight, too. When you get hungry, you just let me know. The pizza man is on call.
The trouble with that is that I know...
Not much gets done after the pizza gets here, though. That's the problem.
See, the difficulty is I know that since you so deftly set me up about not buying at the contest Sunday,
oh, yeah.
I know I'm on the hook for tonight.
No, pizza's on me.
I can feel that stainless in my mouth.
Pizza's on me.
Bingo. Anyway, first thing we're going to do is just find a center, either one, okay? You can find top center, just take a pair of calipers, okay? I have a pair of dial calipers which Dave Evans sold me at a junk show for $12.
My price.
Can't get it no cheaper than that. They're just fine to work with. They're
plenty accurate for this.
Exactly. You can get into depth mics if you want. For what we're doing, we're not going to get any closer to the truth by having a better measuring instrument than this thing. The easiest way for me to put the engine on center is just to take the mic and run it down hard against the cylinder at the bottom. Okay?
So you're at the bottom dead center.
I'm at bottom dead center. It doesn't matter which center we pick. I generally pick bottom center just because that's the easiest one to
maintain.
You can just do this, just push down hard with the caliper, and you're on bottom center.
Okay.
Now, due to the fact that we have a very non-scientific, non-standard pointer, we have to bend things around or move the degree wheel from bottom center to try and find zero. And it's going to take a little while. This is not a pro stunt timing setup. We're kind of messing around here.
Well, no, the whole idea is if we were willing to go for drag racing money, we could just send this engine out to somebody, have them do it. The idea of the video is to say a person who thinks they'd like to try doing this, maybe to an older engine, to just hone their skills.
Yeah.
You know, this would be a good choice to, especially if you were going to put a new piston and sleeve in an older engine, and you want to try this. This is one of those low risk, low money.
Now, here's another thing you can do. If you don't have a caliper, you need not run out and buy one. Just take your thumb, put it in a cylinder, and lean on the piston, good and hard. Put some pressure on it.
Okay, now he's got zero lined up with the pointer. And of
but
course
you can feel where the middle of things are. You just wiggle that rod back and forth over center while you're pushing on that piston hard. You're putting, you know, I'm making the tip of my thumb white and dented. I'm leaning on it. But if you do that and you wiggle the thing back and forth over center, you can come within a degree or two. You feel where the resistance is on each side,
and
put it in the middle, and zero it. And that's pretty close to center.
For what we're doing, I think it's perfect. I mean, in a racing engine, I know this would be, everything would be in millionths of an inch. Like when we did the Yamahas years ago, everything was, oh, geez.
You don't want to try to degree a cam.
Suzuki valve shims are within thousands.
Yeah, you don't want to try to degree a cam in your small block doing this.
Right, right.
But for our purposes, you can get most of the way home with very simple hand tools. Okay? Now, I'm just for my own purposes, because I keep a library of this stuff. Every time I do an engine of any kind, I just fill out the whole sheet. So I develop as I go.
And you have a library book when you're done.
Of sheets. When I'm done, I can go through and pick. I know what this motor weighs. I know what rod length there is. I know, et cetera, et cetera. Okay? So all I want to do for now is just measure up the 7 or 800 thousandths without scoring it that the bore is. And it's 840.
840 is the bore.
8 there, 40 there. So 840 is the bore. And the stroke is?
Stroke is the dimension the piston travels up and down, and it's...
Just so we get the idea here, the way to measure the stroke, you have to be careful. This caliper, it's fairly hard stainless, and the edges are square. So when you're putting it into
you don't want to gouge it,
into the bore, you want to be a little careful not to gouge, okay? But if you balance the back of the caliper on the top of the bore like so, push down a little bit, and then use the wheel, you can measure the distance from the top of the sleeve to the top of the piston at bottom center. Okay? And that's 919. Now what we're going to do is measure the distance.
Good point. You want to make sure the cylinder, the sleeve is already down.
You want to lean on the sleeve. And from that we drew 183. So our stroke is 836. So this engine,
it's a square engine.
Bore to stroke is about square.
Square engine.
1
now,
to 1.
Over square being
bore bigger than stroke.
And under square, Kawasaki 500.
John Deere tractor is under square.
Okay, Harley Davidson, just a
piston this big around.
And a stroke a mile long.
And a stroke that goes...
Right, railroad engine.
Exactly.
Right. Kawasaki 500 is an under square.
Now, connecting rod length, I'm not going to measure it yet. I don't want to take it apart just yet. I will measure it because it gets to be very important. Not that we're going to get this far with this engine. This thing is I am fairly sure, having heard them run, that this is a lot closer to a real stunt motor
than a pylon engine.
Than a pylon
engine. Yeah.
We're not going to get this far, but for my own library, I always like to know the rod length of an engine I take apart, because if you get to the point where you're converting, and FP is a good example and HP is another one, if you're converting a sport RC or pylon racing engine to stunt use, you're going to want to either drop the sleeve in the case, raise the top of the exhaust ports, or substitute a longer connecting rod. Very few people know about that trick. But if I develop here a rod that's, say, 20 thousandths longer than an FP rod, I want to know that, because that may well fit into a rebuild on some other engine on another day.
There may be a day when that rod will fit into an HP, just for an example. Not a good example, but I know Paul Walker at one time was maneuvering parts from FPs to and you know what I'm saying. I guess if you take all the engines in the world apart and throw the rods in it, you'd find one that was either real close or I mean, I know that
you have to make new bushings for the ends or bore. So,
does Richardson still make rods? You still can call them up and just get one with
or PM.
Anything you
rods. Let's see. I forgot a flashlight. Here we are on national TV, and my decrepit body has failed again. I now own...
I told him to wear a white shirt. Look what he wears.
Genuine old fogey reading glasses.
Oh, my God.
What we're now going to find is the intake and exhaust timing on the sleeve. for our purposes, this kind of an engine, I will probably ultimately measure the crank timing if there's time. The crank timing is not going to turn out to be critical for our purposes. What is going to turn out to be critical is first the exhaust duration. Anything above about 140 degrees exhaust duration is trouble.
It's wild.
Right. That,
in a hurry.
That gets you into, if you're anything with a high-pitched prop, if the prop is pitched at above about 4 inches or so.
10-6, you're gone.
10-6?
It's off to the Schnurly shuffle.
10-6 on a windy day.
Yep.
You're going to
the
need...
third loop, you better be holding on.
You're going to need both hands, and you need a good stout pit crew to hold you down, because, well, away she goes. Okay. What you need to do, first off, is tune up your eyes. Use your flashlight, shine it in the exhaust port, and you'll hear me say this a few zillion too many times. Just wiggle the pieces. Just look down into the sleeve while the piston just clears the exhaust port. You're going to get used to the reflection on the edge of the piston. What you want to do is bring it up till the light just goes out, right there. You can get to within a degree or so this way. The trouble with this is, this engine is very well built, very clean inside, full of oil, so it won't stay where I want it to stay. The key to that is a small piece of masking tape on the prop driver, just to put enough stiction in so I can measure it. But why don't you take a break and grab the phone if you want one, castor goo and such off the motor. I just wrapped a piece of masking tape around the front of it. Okay. So now it's got enough stiction to where it stops.
That you can stop it in the position that you want it.
I stopped where I want it to stop. Okay. Now we're going to look again. With this motor fitted as well as it is, before you take a reading, just make sure that sleeve is seated in the case, because if you turn it, without it, there's, she moved. So when I push it down, it's going to reseat itself. So you do want to pay some attention to that and make sure that it doesn't get too out of position while you're taking measurements. Okay, so that's one. And that's showing us 44 past 0. Okay? So now we'll turn it around. You know what I did? I just think that I spun the wheel on the shaft. It didn't feel quite right.
You want to tighten it up?
Yeah. I'm going to tighten it up. This will destroy our 0.
But what's a good thing to mention, and this is the kind of stuff I like to get on video, the average person, when he does this, has problems. It doesn't go like you're in a hospital ward. Oh, yes, hand me the thing, nurse.
No.
So these are the things you would want to monitor from time to time. Make sure that didn't move, make sure the sleeve didn't, or the video is no help at all. It's just an ego trip.
3/4 of it?
Yes.
And it's the same way when you...
3/4 of it is figuring out what you did wrong, and
here's the same thing.
The shim on a Brodak mold is to get it even.
And that's just because somebody felt when he poured the mold.
Right. The thing just went.
That moved.
Exactly.
Uh-oh. That's true. Do it over. Same thing here. I'm turning it over and...
Right.
Uh-oh.
Exactly.
It's just feeling with your fingers.
But correcting all these little idiosyncrasies is a big part of being able to do this kind of work.
So we're back up to where the light just goes out, okay? Now, it's off-center, but we can still get to the total exhaust duration by just subtracting
just interpolating the numbers,
okay? So that's at 64.
And the other choice would be if you wanted to make another pointer, move the pointer, whatever that would entail.
And now we're going to turn it down past bottom center.
Now, I don't know by degrees, but it looks like that's a pretty large exhaust port for this size engine.
Yes.
That has the look of a nice, healthy exhaust port.
Okay. So we're going 60, 70, 80, 90. Back to 0. And now we're up to about 30 degrees. Okay? But now we have to count on the degree wheel. And I'll just do this with counting. You can do it by zeroing and all. We started here at 64, okay? And we went 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 20, 30, 40. So we got an exhaust duration of about 146. But now to check that, I'm going to stop, do it over again, and this time we'll set the degree wheel and the pointer at 0 accurately. If you center the degree wheel, then all you have to do is measure one side.
Right. Right.
Twice that number
Double it and you've
is
got
both sides.
You got the exhaust
and it gives you a real nice check. Doing this by hand, I've always found it's better to never write down the first number you find.
Right.
Do it again.
Right.
Do it a third time if you want. Just take your time, feel your way through it, and when you're satisfied you have the right numbers, then you write it down.
Another thing, like when you're doing this kind of work on a Yamaha, for instance, everything is physically bigger, so it's less of a precision job per degree. There's more thousandths per degree. When you're cutting the windows on a Yamaha, you got a little bit of slop there. It doesn't have to be exactly to a millionth of an inch. This has the look of it, such precision to begin with.
Yeah.
You would want to maintain that. In other words, when the port window opens, it isn't on an angle even a millionth of an inch. That whole thing wants to open all at once.
Yeah. When you know what will help here? Do you have?
Tell
I
me
don't
what
want
you
to.
need.
I don't want to wind it down so big that you can't even feel it. But if we can get this thing set up with a big C clamp. That's
Sure. Oh, I
thing-
got clamps away. Let me go get
One
some.
thing that I generally.
Like 80.
Yeah.
And
Yeah.
a kid hits a bump in the moped, them, you know how they are, the frames are cans and stuff, you know.
Yeah,
I mean,
and
they
it
don't have a
stretches.
frame. This thing got about a 110-inch wheelbase. The motor's dragging along the ground.
Rich used to be in the motorcycle business, and he's telling us one of his adventures, one of many adventures of
Oh dear.
Now I had the honor, I guess you know this, of working with the guy who's now the head of the Honda Racing. He was my tenant at one time, and I used to watch him do these things, and I was amazed it would take him hours to do one little tiny thing. But of course he was getting paid a lot of money, unlike the operation. He wasn't getting paid in slices of pizza. You know? Boy, I just hate when they degrade me that way.
Okay. Now we're happily at 0.
Okay.
And we're going to bend ourselves around. There it is. Till the lights go out. Okay, and that should tell us that from 0 to here is 65 degrees. Okay?
And if it's 65, you know.
Twice
Double it.
that is 140.
So you're assuming
130 plus 10. Or 130. Aha.
135, 65 twice.
65 twice is 130. Okay, now let's double check it and see what we come up with.
That would be a real nice low number.
That would
Wow.
that would be really nice.
I mean, anything under
I'm not-
140 is gravy.
Exactly.
You wish you could get it 120 even.
Yeah.
I thought it was going to be 140. For some reason.
That's what I expected, but this is.
What's a
John-
Tiger 60? 140?
Now I'm showing 69, and it did. All right, there's a little bit of hysteresis, pardon me, in the masking tape here. So let's just take our time and make sure it doesn't move. Okay, now I believe 68 is the right number, so let's just try that. And now we're going to check it and go around to the other side and just see how far from 0 we get with that one.
What's the field look like, Rich? Were you up there today?
Not today, I was there yesterday.
Tom said somebody was out there. Ostello said somebody was out there flying already. It's a broken
Okay.
prop and fuel on the field.
Yeah, there's
Now I'm
stuff.
getting 81. Okay. So I'm going to write that down. That's 68, 69, 68. Let's see what we come back. Let's come back to the same 68 on that side. So it's 68 down to 0. Now I have got something funny here. This is not happy because
That liner moving, you think?
I'm not sure if the liner is moving or if I didn't zero it. I'm coming up with 80 on one side. Oh yeah, okay.
Pointer move. Maybe I walked into the pointer while I was videotaping.
Why not a piston stop?
Because it requires stuff, Rich.
What's it require? a piston stop. It's a
Yeah.
piece.
Yeah, it's a piece.
Take the glow plug out and put
Take
the
the glow
piston
plug
stop
out.
in there.
Drive a 10-penny nail through the hole. Okay, so we re-zeroed, and we'll just go back through nice and slow and see what we come up with here. There, that's got it. That's 79 on that side. And we'll twist it around. That's 73 on that side. That's decent numbers. That's about as close as we'll get
That's 150 then,
with the hand crude stuff.
So,
So that's 145 in
okay,
there.
what I'm getting at is
Okay.
if it was 140, it would be like what a Tiger 60 is, just to make
Yeah.
a ballpoint. What is a Fox 35?
Fox
Lower?
35 is...
You got the
tell you
sheets
on
there,
the
I know that.
nose, 130, 132.
Okay.
I'm gonna have
For
to-
some
this is-
reason, I keep thinking ST60 was 140,
We're
but
going
I
to
could
get
be
to the
wrong.
bottom of the pile here to find K&B 40 stunt. I did measure one before,
Oh.
12,896.
Okay.
Okay, I got 144, so that's the same.
Well, we're pretty
Okay.
accurate on that.
You're leaning-
Here's Tiger 46. You just want one.
Fox 35, 54, 124 and 115.
Okay.
Okay. Interestingly enough, we just got some numbers from Bill Mazzoni on the original George Moore specials, the 29s reworked for team race. One of the first things he did is to take the Fox timing and raise the intake and exhaust ports both to make it a higher speed engine.
Yeah.
So
Yeah,
he's
raising the exhaust is no
he's going
secret.
the other way.
There's no secret what to do to make
yeah.
it make more
He's going the
power.
other way. Okay, so we've identified our exhaust duration as either the sum of 78 and 72, say that's 150, or the sum of 68 and 79 divided by 2, so that's going to be 142. Okay? It looks to me like
That's
what we've
on the
got.
high side of 140 would
Right.
be a good way to
Right.
to phrase this.
I'm going to put down the same thing I got before, 144. Okay? That's our exhaust timing. Now, what we're going to find is the next thing we want to do is measure the bypass timing, the intake timing. Now,
Okay.
this sheet,
Well, we got to get to the other side to do that. Or
Okay.
you have to get to the other side.
this sheet has a whole lot of stuff. Bypass timing and then boost timing, which we don't care about. Boost timing refers to the port opposite the exhaust port for a Schnurl ported engine,
Okay.
a 3-port, where the primary feed is the fore and aft angle ports that feed columns of mixture into the chamber that aren't aimed at the exhaust port. This engine is an oddball, and I don't understand what the deal is. It has peridirectional ports
It's PDP.
down here, okay,
Right.
and
It's kind of a unique setup,
a
actually.
bypass that feeds across a flat top piston. Now, after we pull the sleeve, we will see that that bypass port, I'm sure, is angle milled. You don't do that on your Bridgeport. You need your CNC,
Right,
and
right.
you know you got to spend big bucks. That's angle milled because a traditional
Oh,
setup,
yeah.
a
Yeah.
K&B, a Greenhead, a Johnson, a Vico, an old
Right.
Fox, you take the baffle off the piston. As soon as the mixture comes in the bypass,
It's out the
it goes
exhaust.
right out the exhaust.
Yeah.
You get nothing other than a big fuel bill. Gee,
There
that
was-
wasn't too good.
Yeah,
that
there-
wasn't in the right direction.
I had a couple of Tiger 60s that people sent me that said didn't run. They were reworked by somebody and had half of the piston baffle taken off.
Okay.
All you need to do is buy a piston,
Yeah.
and it's back to one piece.
Yeah, yeah.
I guess at one time somebody was trying to make Tiger 60s more powerful for whatever reason.
Okay, now, we want to measure the intake timing, but that's not too hard. If we start where the exhaust shuts off, so the light just went out as before, you can just see that little eyelash of light from the flashlight. Now what we're going to do is take a look at that. That measures the same, see if I can read it upside down here, 74 degrees, okay? Now if we turn the thing,
This is where the laser thing would be real nice. Boy, that would be beautiful.
I'm going to buy one of those. They're 30 bucks.
They're $30 in Home Depot.
like
How the
so.
hell can you not buy one?
Pointer.
Yeah, laser pointer, yeah.
Now
You
we're
lay it on
gonna
a table and it points on a wall, it points on anything you want.
Now we're going to find where it's 65 degrees. So this thing is obviously not an RC Sport motor. This thing is timed for stunt, or at least mostly so. What
It's
they've-
more mild than times
Yes.
for high power output.
Yes, right. I'd like to have a little less exhaust duration than 144, okay? But 144 minus 14 is 130. The reason it's 14 is we got 7 degrees of blowdown on one side. That's pretty much the optimum figure for a 2.4 brake stunt motor. There's two sides because the other half of it we didn't measure over center yet. So let's put the bypass timing in at 130 degrees. That means that what we've got is an engine that's going to give us a 2.4 brake. It's going to run like a stunt engine should, but it's going to want to run a lot faster than a Super
A
Tiger.
fast 2.4 brake instead of a grown 2.4 brake
It's
like
gonna-
a Fox does.
I'm guesstimating at how the rest of the gas flow is going to work, but it's going to want to launch at 9,600 to 10.2 in that range.
90,
and it's gonna,
94, 95 is where it was real happy, yeah.
Okay. You're probably going to find, without any changes to it at all, that with exhaust timing that's that fast, you probably want to run somewhat less prop than you would if it were a real grunter, a Tiger 46,
Right.
growling off the deck at 8,700 and coming up on 9,600 full throat. This probably wants the way it is, and 11.4, fairly skinny on the blade area. If you want to twist it up and not be afraid of the needle valve, you can probably go to a 3.5-inch pitch prop and have it work pretty well. This will still run away if you're running an 11.5 or any prop with a lot of blade area. This is still going to give you a good bit of the race engine two-step, as we have seen.
The two-step we have.
The snarly two-step.
Now, what I found as the best prop after doing about 25 of them is on the plane. It's 11.25. You can see it's got a
Right.
tremendous load.
Right.
And all that did, that acted as a just keep it from running away when it wanted the two-cycle operation. I mean,
Okay.
I tried all the APCs that Rich gave me, the ones I bought, John Brodak gave me some, and the only thing I experienced was very weak line tension on that size plane.
Okay.
Maybe appropriate for a nobler size plane. Certainly for
When
that
you-
size plane, it needs a prop.
When you tried the
We went
the
through about
11.4,
25 of them.
say, one thing that might have helped there is to not be afraid of the needle valve.
Yeah,
You know,
yeah,
if you're
exactly.
going to run that kind of a prop and get this engine
Right,
to where it won't
right,
run away,
right.
you're going to have to wind that valve right down.
we
You gotta
ran
bring
some-
the RPM up.
When we were in Middlesex, I even got video of this. We had I had Kyle doing a test flight, and we had some, what I call, let's run it.
Yeah.
And let's just see.
Just twist
And-
it down.
Yeah, and it really, it got to a certain point, and it wouldn't go any faster. But I don't
That's-
know, the problem I was having at that point in time was that the fuel consumption got down to 2 ounces or something. It just would run for 12 minutes at that.
Okay.
So you would have to
Okay.
calculate that out if you were going to go for that kind of a setup.
Right.
And it's my feeling that nobody in the real world of big stunt even tries that anymore. That it's too difficult to keep fuel consumption. And I mean, everybody has
Okay.
basically gone back to a little bit richer, a little bit of a motor run.
A little bit of
what
a
we feel
2.4,
is a motor
little
run.
slower. Okay.
And the videos, by the way, I happen to confirm that nobody is running a one-speed motor that I can
Yeah.
tell. If there is, they've snuck it by me for the last 3 or 4 years.
Okay, now, one other thing that I've noticed that I'm not sure how John and K&B did this motor. I don't know how it came to be. I know the one that I happened to measure before.
Yeah, you already got one.
I think it's Rob Sabatino's. Somebody bought one from John's. It might have been him or Don McGregor. And I just said, gee, can I borrow that?
It might be that's a different motor.
I just want to time it.
Yeah, that might be a different motor
The
than
sleeve
this.
timing is the same, but I remember from looking at that motor when it was in the box that it had the standard RC parts list,
This one
except
doesn't.
for the Venturi insert, the spray bar assembly. The piston and sleeve numbers, the head numbers, the rod, the crank, all that
same.
stuff was the same numbers. I figured from that, gee, it's probably not a special stunt liner. They just build their RC motor
Yeah.
not to come on quite so strong. Okay?
That's a good point. I don't know the answer to that.
This one, with 7 degrees of blowdown, but that fairly long exhaust duration, this one may want to come on a little hard. So let's pull out the ABC treasures here and have a look. And sure enough, the thing that keeps us from sending the charge right out the exhaust when the piston's at bottom
It's
center
angle milled, sure.
is those ports are angled. that directs the charge upward, we
Right.
hope. Some of it goes across. With a Schnurl-ported engine, this port here, opposite the exhaust, is just straight across, and it's not very big. The ports that charge are this size and shape,
But they're on the side.
but they're on the side, so that the primary charge is not aimed at the exhaust. It's
Right.
aimed either across the cylinder, or Foxes have it angle milled so as to direct
Away
it
almost.
away
Yeah.
from the exhaust.
I've seen it. Yeah.
Okay? That gets you to why this squish band head works, okay? I'm, like everybody else in this stuff, I've never been inside an internal combustion engine while it's running, so none of what I say is absolutely known to be true. It's all black magic, because
Yeah.
nobody can look inside.
Yeah.
The squish band does a couple of things. It encourages turbulence because, as the name implies, the piston squishes the mixture against the band and makes it rush into the chamber right at the moment of combustion. The other thing that it seems to do is the squish seems to scramble the mixture when it comes up into the cylinder from the impinging columns. I've never figured out why, but the next chamber shape that the speed and team racing guys use is a double bubble, one of these with
Right.
2 bubbles and another lip. That
Right.
scrambles it a little better.
It seems to work better
Right.
in racing applications. Yeah.
And the Fox heads, Fox builds some heads that are just awful, that have a squish band about 2/3 of the bore and a little tiny, very deep dome right in the middle. Those heads just pre-ignite all the time. You can't get them to deliver
Wow.
smooth, graduated
yeah.
power. As soon as you take one of those head buttons and turn it and open it up to this chamber shape,
Everything's cool.
the whole engine gets real
Right,
tractable. The whole
right.
thing gets real friendly. It works just like you think it's gonna.
Now, the theory that you probably would confirm is when Big Jim used to rework Tigers. This is basically what a stock Tiger looks like.
Right.
He would turn this into a Hemi dome with no squish band.
Right.
And what his feeling was that if the compression was over 150 pounds, you should run a squish band
Right.
to avoid detonation. You get that trapped gas in there that isn't subject to the flame. But under 150 pounds, which is where most stunt motors really are, that the Hemi shape gave the advantage of dissipating all the heat, just like a Chrysler Hemi does in
Right.
the world of drag racing. That's the reason Chrysler Hemis were so successful at fuel drag racing. It has the most surface area of any shape you can make.
Now, what I want to do next is just have a look, and this next little bit. Whoop! There goes the gasket. Well, let's take the gasket
I
out.
can get more gaskets
No,
if
no.
we need them.
No, we didn't break it. I just want to get it out of the
Okay.
way before we do. That's all. Okay. I'm going to nurse this rod off the pin, and we're fairly loose. Okay, but not quite enough. I love to be able to do this with my fingertips if I can, because I know
Yeah.
I'm not strong enough to hurt anything.
You're not going to hurt it with your finger, but you reach a screwdriver or pliers or
You may have to.
a hammer is my favorite.
A hammer.
Give me the hammer.
We will make it fit.
Sam Shirota would get that out in a minute. On this kind of motor, I would be thinking take the front of the motor off.
Yeah, I'm thinking that that's how this was assembled, because it's
Yeah.
pretty clear that that piston does not come out without pulling the front.
Right. On Tigers, you know, the back, that little
Yeah,
plug comes out or
right.
whatever you
There's
want to call it.
there's for taking other motors apart.
Yeah.
If it's a Johnson, a McCoy, a Greenhead, the whole sleeve lifts out,
Oh, yeah, then you're...
and the piston's sticking up, and you push the pin out.
Push the pin out,
Okay.
right.
With a Tiger or a Fox Rocket, you pull the sleeve out, and there's a bore at the back of the case here that
Right.
doesn't seem to do anything while the engine's running.
Right.
That's there so you can put the wrist pin in, so that the pin bosses on the piston can be wide, so you don't have to be able to slide
Right.
the rod off the wrist pin and accordingly make the bosses real skinny, so they wear out quick.
Okay, one thing that looks nice on this motor, the castings look like they're really nice.
Yes.
I mean, when you look at all the casting work on this is
No, this is
real nice quality stuff.
Yes.
I guess the only one that would be, you know, I mean, when you look at a Tiger 60, it's nothing like that. You see these flanges and ridges and grinding marks where the pepperoni went in when they were doing it and stuff.
I don't know. And it's hard to
Old
believe.
Tigers, it's hard to imagine the new ones aren't made on NC machines, but the old ones I'm sure weren't.
Yeah, yeah.
Some of the old 56s and 51s I have really look crude. You wonder if they had, what tooling they had after World War II, I don't know. I mean, look at a Ducati, there's a good example. Now the modern ones are beautiful, they're Rolex watches, but look at some of the old ones.
Were
old.
they were
Ooh,
crudely done?
crude.
All right.
Yeah, crude.
All right.
There was some rough castings, rough sand cast stuff. But the new ones, if you look at them, you would think they're made at the Rolex watch factory. So you know, their stuff has changed too.
Okay. Now, we're suffering from the too short wrench syndrome. So if we had a T-handle driver or a ball
We
end,
may have one. Wait,
we
wait,
can just spin
don't
it
go
right
away.
out.
Let's look at our handy Home Depot list here and see what's over here,
handy dandy.
which has guaranteed every tool
There
except
it
the
is.
one you need. There
Bingo.
it is.
Hey there.
Just
There
like a
it is.
brain surgeon, you reach in and there it is. We don't want to lose that needle valve setting, do we? Heaven forbid.
No need to. No need to. One thing I never do is touch the needle valve. Needle valves, if you leave them alone, can furnish you with a very handy and nice to have reference for when the plug is going away. When it's got that white stuff on it before the fire goes out.
Before you lose it.
Before the fire goes out, while it's still together, it's got that white stuff on it, and that'll make it come apart. Now all I'm doing is just wiggling us apart here. You don't want to push on it hard enough to cock anything sideways.
Now it'll.
Now we got it. Now the whole business just fell apart. The one-horse shay effect. What I want to look at now, the thing I'm very curious about with this engine, and it may be a piece of our puzzle here, is the depth of the bypass. This is something that I first saw, I'm going to say 6 or 8 years ago. Ski Dombrowski had a Webra 40, very similar engine to this,
Right.
heavily built, old line manufacturer, high quality, double ball bearings, ringed, a conventionally ported engine. I believe those engines have baffle pistons, but like an Enya from the outside, unlike this, it had an enormous bypass, like
Yeah.
a dueling 29.
Right,
This
like a
great
dueling,
big
yeah.
bubble designed to feed as much mixture into the head as you could get. That causes some difficulties if you're running the engine rich enough to make it give you the 2-4 brake, because what happens is, not only due to the lubricant, the castor and clots or whatever else you're running in the fuel, but also because the alcohol never fully vaporizes. While the engine's running, there's droplets and rain just splashing around inside that engine every place. If you get too much of that in the bypass, it can all of a sudden get swept into the intake port in the sleeve,
And put the plug out.
get up top and put the plug out. There's a couple of things you can do.
Carrier
about
guys, I guess, in some you see carriers where they just get it, and
Yeah.
then what, and then
and then
it's gone.
it quits.
Right.
Right. That's because when they were idling, if they have the idle set too rich, they got the bottom end of the crankcase full of raw fuel and oil. And as long as they didn't open the throttle, it stayed alive. As soon as they opened the throttle, what was downstairs came upstairs. Same thing happens when you have a guy who's trying to start a flooded engine. Flip, pop, 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 pop,
Right.
pop, 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 pop.
And every time it starts, another drop goes up and
Every time
shuts the fire off.
it fires, the
Right.
piston comes down
Right.
and squishes a whole bunch of
Right.
oil up there. The thing we can look at doing on this motor, and I'm not sure we want to, is to partially plug the bypass. Not the directional ports on the sides, but the bypass. What we're going to do if we do that is to increase the mixture velocity through the bypass,
Right.
so as to keep the droplets suspended and hopefully prevent some of the excess richening that happens. I have had that modification work very, very well for me on side-mounted Foxes. Everybody's seen a
Right,
Ringmaster with a Fox.
Yeah.
The kid does the reverse
And it
wing
shuts
over.
off. Yeah. Right. Now, what's an appropriate material there, JB Weld?
JB Weld, or if you want to be high-tech, a popsicle stick will work just fine. You stick it in there, you put the sleeve in, it's locked against the bottom if the sleeve hasn't been polished,
Okay, and it can't go anywhere.
and it's locked against the top and it can't go anyplace.
Yeah, real high tech.
Real good idea, however, to check the bottom lip, because if it can
If
go
it doesn't,
down, it fouls the crank web
Right.
and it stops in a big
Right,
hurry.
right.
Crunch, ouch. My guess from looking at this one is that a plug in this bypass, either by way of JB Weld or wood, is something that we might want to try.
And you even could do it with, I'll tell you what, I can carve one out of a piece of hardwood maple.
Yeah.
It's no big deal.
Right.
I can carve that. And if it doesn't work, how much of a deal is it to take the motor apart, take it out, try again?
Pull the head.
Right.
You got to take the motor apart, because this engine, you can't get the piston out.
But the difference would
But
be
it-
with JB Weld, you'd really have to Dremel it out.
Yes.
So
Yes.
so as an experiment, it would be easier, cheaper, and quicker. Let's make a piece of hardwood.
We can get a piece of popsicle
Yeah.
stick from the corner
I have a few pieces of, Tom, in case you didn't notice, a few pieces of hardwood motor mount here somewhere. We have a few. 250, I think.
Is this is high tech?
Those are the ones John Gajewski makes. These
Okay.
are the ones John Gajewski machines up, and I make them hollow and square and all the other
And they're
baloney.
planed and they're square and they don't
Oh,
warp the
they're
bearers,
beautiful,
and they're
yeah.
just hot
And we wind up
stuff.
throwing 3 out of 4 away because even at that, they don't all come out perfect.
Okay.
You know, when he buys a select piece of wood and then cuts it, you throw 2 out of 3 away.
Not relevant to the tape, but when I build a crutch, I always build the crutch and then put a piece of paper down on the glass and scuff it back and forth to get it dead flat.
Yeah.
You do the same thing, or you,
No,
if they're
I
not square,
throw
you
'em away.
trash them?
Yeah,
Okay.
I trash them.
Okay.
I just get an unlimited supply of them and trash the bad ones.
Okay. Okay.
Sells them to me.
I give them to Peabody.
Give him the Peabody. Okay. Poor Rich. This is.
Boy, I thought he
must
was going
say-
to bring a pizza. Now, see, the fact he didn't even he didn't. Not that you would expect. He might,
no,
he
I-
might think we're hungry and thirsty.
I
or,
think we should call the United Nations in on this because
Yeah,
we
this
have
is a
now
UN
had
job.
we have had silence from Rich Peabody for a
Yeah.
grand total of 9.74 minutes.
The Iranian embassy is probably in chaos.
This has to be.
Their phone's ringing off the hook.
Did you look at this?
It's a world
this
record. Did I white
This thing he's building over here?
No. What's he?
Look at what he's building there.
Oh, we'll take it out later. We'll play with that while we're
This
having
thing with
pizza.
up on the rack here.
The I-beam, the one in the middle.
Oh yeah. Okay. No, I did not look at. I mean, I saw it, and it's a Beamer, obviously, but I didn't.
Yeah.
I didn't fondle it yet. I'm too busy.
This
looking
shows
at the
a
K&B.
man That's completely lost.
Completely gone. The mind is like this engine.
He can never say anything to me that's going to be.
Relevant to humanity.
Winnie, what I'm going to do at this point is I want to just run the.
Get an idea of the depth of that.
Exactly, because what the Fox, which is the only other engine I've ever plugged, has a depth of about 3/32, and if you move it to half its depth,
Okay.
you get this beautiful correction of that outside profile-mounted
I've heard
outside
this.
turn
I've heard-
rake and
yeah.
rich.
Yeah, and this motor, by the way, doesn't exactly have the Fox thing, but it's got some what I call uncorrectable funnies. The tank always having to be
Yeah.
high.
Right.
I'm sure that's part of it, that the gas is always going
Yes.
over the top.
On that one, Wendy, for Tom Morris, if he sees this, you should get.
I'll send him a
everybody
copy.
should-
It's no problem.
Everybody should get Ted Fancher's columns from Model Aviation in the mid-'80s, I'll
Yes,
say.
yes, mid-'80s, right.
Among which is the column where he describes the center of pumping action of
Right.
a two-cycle engine.
Right.
Mr. Fancher, I didn't have a hat on, but if I did, it would be off to you. That column was right on the money, and I
was
come
excellent.
back to that again and again and again and again because he was right on the dot.
It has nothing to do with where the spray bar is.
Spray bar doesn't make any difference. The center of pumping action of the engine is at about the top of the bypass. Depends on how the crankcase volume is distributed. And it's, especially for a loop scavenged engine like this one with no Schnurl ports feeding the sides of the chamber, it's offset to the bypass side so that you, to develop Ted's center of pumping action, you get the exact center of the internal volume of the crankcase.
Right, almost
Okay.
like figuring out the mean average lift point on a wing.
Absolutely.
Almost the same thing.
Same deal.
By the way, another thing that's really neat, when you plug up anything inside the crankcase, anything, the engine's going to draw fuel better.
Yes.
You're reducing the internal... Before you got here, I did a little dissertation on why this engine has a tremendous amount of power potential, just for the fact that it can pump more air
Right.
than a little tiny engine.
Yep.
A bigger engine will always be able to pump more air.
But read in the latest stuff.
Yeah, Ted's stuff was excellent. I remember that article.
Ted's stuff was fine, but Scott Baer in his stuff does a expose on spray bar carburetors. They're pretty clearly
Right.
not the way to go. I've only felt that, gee, a spray bar doesn't quite break as sharp as a true Venturi with a feed hole in the side or a little jet tube that sticks out.
Right.
And I thought, gee, that's, you know, it happens once and you don't believe it, and then it happens a second and a third and a fourth time, and after the 20th time you think, yeah, I'm onto something there. I really am seeing this. I'm not fooling myself. That's true. Scott did a whole bunch of tests checking vacuum inside the crankcase while the engine is running, and it's true. A true Venturi does make higher vacuum. It pulls the fuel out of the tank harder, so the run gets steadier.
Do you remember Al Rabe, speaking of old Ted Fancher columns, Al Rabe had a column, and I don't remember how old it was, where he made a threaded Venturi so that this could be threaded in the plane?
Right.
Remember that? I don't know if it's the same
I never saw it, but I'll bet it made no difference.
None whatsoever. It went to the end of the travel and the back and nothing
ran
changed.
The same way.
Like Billy Simons made a tank with 3 pickup tubes, so you could just put the thing on. Made no difference at all.
Yeah.
Yeah, so a lot of that was nonsense, you know?
Now, we're off the spec form here. What I'm going to do is I'm going to just write out bypass depth, and the depth to the sleeve is, and I'm just measuring from the outside of the stack to the sleeve, is 1.338, okay? And now I'm going to measure across, instead of hitting the sleeve,
all the way in.
I'm going to cant it down enough so it hits the inside. Whoop, I'm going to unlock it first is what I'm going to do.
As we said in the earlier conversation. Yeah, I like the idea of taking a piece of wood. You can put it, actually, the other choice you have, you can make bigger or smaller pieces of wood.
Yes, yes. And your chance of ultimately ruining
an engine. And if a piece of wood runs through an engine, nothing really terrible is going to happen. Even if you ran some of it through, the world isn't going to end. You run a stone through, something bad can. You don't want to make that out of
if you catch it in if it gets chewed up and you catch it in an exhaust point, you're going to bend something.
Yeah.
Okay. Anyway, if you slice the block in half vertically, you'd see that the top of the bypass has a curve to it. What I did is to feel with the foot of the caliper until I got to the foot of the curve.
Yeah, so you're not measuring the radius,
I don't want to measure the radius.
Wall.
I want to measure the flat wall,
right.
But I don't want to go down here because then I'm sticking the caliper down.
Then you're on an angle and you're getting a crazy
angularity.
Angle.
So by approximation, by the famous Larry Scarinzi exact scientific approximation and guesswork method,
that's what we all use.
We have 1.551.
Doesn't this look like a dog that's going to bark and bite?
Okay.
Pretty nasty looking stuff.
So that's 0.213, just under 1/4 of an inch in depth.
Whoa.
From the...
Wow, that's too... You're kidding me.
And let's hold the sleeve up. I'm just going to partially insert the sleeve in the case.
That's
so
a giant amount.
In your mind's eye,
run
the edge of the sleeve down into the
block.
It's
1/4 of an inch.
The edge of the sleeve runs here. The outside of the bypass is here. So I think one of the things that I would try first, before we fire up the Dremel tool and the Bridgeport and the foundry to make new pieces, let's just take and measure up this bypass and cut a plug and try that next.
Yeah, absolutely.
And let's just see where we come out with that one. None of this.
This is really, this is the kind of stuff I've heard works on Foxes. I've seen several people write about that.
None of this stuff is intended in any way to imply that this thing is anything other than a real good stunt motor right out of the box. This thing is just fine the way it is. We may find some things here that'll make it a little better, but for the guy that's in intermediate and even advanced,
exactly,
he can take this thing out of the box and operationally
buy some APC props,
it is not
BYNOs, and go right up to the field. It isn't going to
hold his flying back by 1%.
No.
I'm trying to meet Wendy Ortnowski's standards, which for anybody that's had their airplane come out in the second row because of his ability, meeting his standards isn't simple. He demands the best, and he generally gets there. But we're going to try to see if we can't make up a plug that gets us someplace.
But there's another good point to this, too, of doing a wood plug. A wood plug is an undoable doable.
Yes.
You make a Venturi, doesn't work, take it out, put the original one in.
Bingo.
You always have your square one to go back to.
Right.
When you JB weld, grind, cut, that's the end of that part if it doesn't work. In other words, you go cut that sleeve all up and you go to the field and it just doesn't work. Buy another sleeve.
Right.
And that can be, I don't know what these cost, but it isn't $5, you know.
If I were home, what I would do with this thing is a real simple way to solve for the contour of the bypass. Okay, I'd leave the oil in it, and I'd put a glop of 5-minute epoxy in there. Order up a pizza, go upstairs, watch the game,
And that would transfer
pop it out, and bingo, there we are with the contours, the depth
Right.
and all. Okay,
Right.
we can come plenty close enough by eye, because we've got on the outside of the case the outside curve,
And that wall
We know the
thickness
depth
really
at the
doesn't
top,
change a whole lot inside.
and we've got the depth and shape at the bottom. It is tapered. It's a little wider at the top than at the bottom. And we know that it's, what, 213 thousandths thick at the top. By eye, it's 70 thousandths, maybe 60 thousandths deep at the bottom, a 16th or maybe a little better at the middle. So we can go ahead and carve a balsa plug, put it in there, eyeball it, and see where we come out. Make a couple of those, and then we'll carve one with hardwood.
Yeah,
The
yeah.
primary thing I want to try is when we carve a hardwood plug, we want to just slip the sleeve in, and then go in here with an X-Acto knife or a pair of pinchers,
Okay.
and
Right.
rattle it good. Make
Right.
sure she stays married where she's supposed to be.
You'd like to plug up roughly how much of that cross-sectional area?
I'd like to leave the cross section at the bottom mostly open.
Okay.
But I'm going to have the plug come down to the bottom so that it can catch this
Yes,
ledge, so
but
it
it'll
doesn't
be
go away.
a minimum on the bottom and then a maximum
And
up here?
we want
It'd
to
be a
take at
taper
least
almost.
half of that thickness out at the top, maybe
Okay.
more.
Okay.
Okay? What I've found with the foxes, I've done, well, 5 of them that I can think of. My brain falls off once a day anyway. Oh well, old age. What I found with the foxes is it doesn't matter whether I make a plug that's full depth down the middle and leave 2 channels, one up each side,
Or put it on
or
one
make
side.
one that's halfway thick and let the mixture come up the whole width of the
Right.
bypass but half as deep. Doesn't seem to make any difference. It solves the outside break rich problem anyway.
In effect, what's mattering here is the cross-sectional area. You want to reduce it.
Right.
That's what you're basically telling me.
We want to get it so there's no reservoir
Right.
of liquid stuff,
Right.
oil and unevaporated alcohol hanging around out here waiting to put the fire out when
Right.
it
As soon
goes
as that
in.
opens, goes like
Right.
spitting on it.
One other thing, tip of the hat to Randy Smith for this one. What I do with any motor that I set up is I have a little annular cutter made out of a genuine Allen cap screw that I chuck the head up in the lathe, run the cutter in like so, and turn a 1/2-inch wide annular cut around the outside of the plug down so that there's about a 1/16 of an inch of material left beneath the bottom of that annular cut. What that does is it allows the cooling fins to cool the block and the head and the sleeve in the normal way,
And leave the plug hot.
but it blocks the thermal conductivity away from the plug so the
Okay.
plug stays nice and toasty.
Right.
That, again, will make an identifiable difference. If you take a Fox and just do that, you should be able to feel the difference in how
Of
well
keeping a plug lit at low
how well it
RPM.
2.4s and how
Right.
well it recovers from a rich burp. It comes
Right.
back to life quicker.
Wendy probably has some 5-minute epoxy, and I see a number right here for some pizza.
Uh-oh.
I don't see a wallet. That's the one thing I don't see. Well, how thick is that? How thick is that wallet? Jesus, it's only 10,000. Where's all the money?
The money? I don't have any. What do you mean?
You ready for pizza, Rich? I can order it over the internet. They bring it through the computer. It just comes out the screen.
Comes out the floppy drive.
Well, we could fill up that transfer port with pizza. That would be a new. Just if you don't have enough power, you just eat the motor.
So how big should I make the hole in the Venturini for my 20 OS 20?
Spray bar?
Yeah,
What's
Venturi?
the diameter of the spray bar?
it's got a carbonator on it.
Oh.
Well,
Nothing's better than a good slice of pizza pie, and let's see how this.
Am I smiling?
This is. I'll tell you something. There's something to be said for that. I can hear the disbelievers out in the world. Ugh,
Yeah.
wouldn't have. Oh,
Oh my goodness, it's crazy. It's lost what was left of its mind. Are we on?
Yeah, you're on, baby. Look at this hand-carved exhaust port he made here.
What we're looking at here is just the block with the sleeve stuck in. It's not turned right or anything. You can see that this is just the second balsa plug that I carved, just playing with the pieces in my hand to see how everything fits. And we've got the lower step in the bypass cut is only about a 1/16 deep or a little less at its maximum depth. The sleeve doesn't extend far enough down into the case to trap
To
that
really
plug.
confine it well.
Exactly, to make sure that the bottom end of that plug stays away from the crank throw. Thank you. So we're off to plan B, which is JB weld. Unfortunately, because of our Boy Scout preparedness, we're not ready. We don't have JB weld.
My JB weld is on Mike Kajeski's The Engine Block that this man erroneously sold poor Mike Kajeski without telling him it had a cracked head or whatever the hell was wrong with the exhaust manifold. He took my whole thing of oh, how about high temperature epoxy? Nah, I wouldn't. Nah, that's experimenting.
Yeah, I don't know. The alternative is to take that little plug, after you make it out of hardwood, of course,
yeah,
and just put a 1/16 square rib down the center of it.
So it would press
so that it contacts the side of the sleeve and presses it in.
Yeah, yeah.
I'm not...
It's starting to sound like JB Weld is the only...
That's asking for it a little bit. So, in the
your
nature...
first, last, and only defense against the worst scum of the universe.
In the nature of all good experiments...
Oh. And that's how it really works
So
at
it
NASA, too.
The JB Weld secret is just, I'll clean it off with thinner, of course, 2 or 3 times. Get it good and squeaky clean. Then I'll take a pinky full of 80 grit, hot stuff it to the end of my finger, go in like so,
roughen it up,
and just break the glaze all inside of that bypass. You want to do it with just the tip of your pinky, and you want to be careful not to upset the bore outside the bypass.
Right, where it's machined, you don't want to have it sticking up.
Where it's machined,
it's got to be a heat transfer
surface to
finish.
surface contact.
Right.
If you upset that heat transfer, this whole piston and cylinder fit that K&B worked so hard to achieve goes right out the window, and the engine is not going to be happy. It might work, it might not, but you're making trouble for yourself. So the key is to be very... You need some heavy grit sandpaper to put some deep scratches in, but you want to be very careful not to
booger that up,
the bore. Okay. What I'll do is just to clip it in a small vise, like so that it's down, and then just daub the JB weld in. Look at it by eye. Let it set up, and then Dremel what I have to out. Wash it off again, and then bolt the thing together. And at that point, we're off to the flying field to see whether we've gotten the.
Oh, then the next step will be right. The next step will be now. What's nice is this plane. See what I've done over here, Tom? Is I've made it that you can take the engine in and out in a matter of 4 bolts. There's absolutely no switching, no nothing. Both sets of bolts, both sets of blind nuts. There's no Mickey Mousing.
Right.
You can leave the prop and spinner on if you want.
Yeah.
I mean, I really took time to make sure this was an interchangeable thing so we could do the real test in the real world.
Yeah.
Not a play test, not a...
Right. But nose to nose.
Nose to nose, same day.
Same weather, same day.
Same everything,
same
right.
temp, everything
right.
the same. All right.
And so what we'll, unless there's any other work you want to fool with here.
I don't think there's anything else.
Anything else you need to...
There's nothing else. What's that, Rich? I'm sorry.
You're going to do the head on that?
Yeah, I will turn the head.
Okay, and you're going to turn and put one of those the Randy Smith little inventions on it?
I'll cut the heat dam in the head.
Okay.
The other thing that you could do is to give yourself a bit of a better counterbalance by just pressing the crank out and grinding the front.
Taking the corners off?
Take the corner off that crank throw there. That'll increase the effective counterweight. This counterweight is sized to balance the engine at an RC operating speed of, say, 11.5 to 13, someplace in that range, flying without dragging a set of lines.
Okay.
We run it slower. We want a little more effective weight. Okay. So that's a way to get it without being too exotic.
Basically, another thing you want to make, at least is a good time to mention it, is there's no way reasonably to totally balance a one-cylinder engine. You try for getting it out of the harmonic range that you're going to operate that engine in.
Right.
Unless you've come up with some clue that I haven't.
No.
Even in motorcycledom, other than running a separate crankshaft, which Yamaha used to do, you can try. Now, if this was geared for 11,000, you can You can cut. I know they used to put tungsten.
Yeah.
Al Rabe used to put tungsten in them.
Yep.
But there's no such thing as balancing a one-cylinder engine.
Not unless,
as such.
Not unless you're going to hang an extra, at least one extra shaft and a bunch of weights.
Counterweights on exactly like a BMW motorcycle.
Yeah. Hang it on the side of the engine.
Yeah.
Balanced or
No, I mean, people misunderstand the word balancing. You're not making it that it won't vibrate at all. You're just getting the vibration out of the range where you expect to use the engine.
Hoping you can get it down to a reasonable level. This, I'll mention one other thing, Wendy. Which is not by any means finished work in my own mind. It is that I'm beginning to think that profiles have a resonant frequency of someplace around 8,000 or 9,000.
Mm-hmm.
And accordingly, I am always much happier on my own profiles to run a high RPM engine, run something that
just let them run.
Spins merrily away at 11 grand, because I have experienced older, soggy profiles that are running Foxes or Tigers or whatever, depending on the size of the ship, that have gotten loose and old, and they shake like crazy with a low RPM engine.
Especially when that wing to fuse joint gets a little oil soaked and cracked,
little wet,
and where the gear go through, it starts softening.
It starts to get nutty. Once that starts to happen, it's a death sentence. I have seen a couple of oldies get saved by just going to a high RPM engine. Don't do anything else, just change the RPM. So I want to do some experimental work at some point, and maybe even some, heaven forbid, math, to figure out what the resonant frequency of the front of that profile nose is. Now, there was a little piece of goo that came out of the, came off the counterweight. I don't know what that was from.
Maybe from taking the engine apart. That's not a piece of machined metal. That's just junk.
Oh no, it's just junk.
Maybe from sitting on your board. It's a piece of wood.
It could be from the board. It could have been inside.
This isn't K&B approved
no.
Easy Just, is it?
No, no. That's ancient castor oil. The first drop of castor oil on that was placed by King Tut himself. It's been getting worse ever since. But these things, of course, look at that hole. These things ingest mosquitoes and such as they roll along. No question about that.
Dave Cook used to make an insert for inside the crankshaft out of nylon to throat that down. So I remember seeing some of his old motors.
Okay.
That was an interesting way of, I guess, accomplishing the same thing, restricting them in some way.
Yeah. Yeah.
I think he was trying to stuff it.
Stuff it, yeah. Well, what people don't understand is, like a Fox, the restriction in a Fox is the crankcase.
Yeah.
You can't pump air through this little. These is the Lincoln tunnel with mice running through them. That goes in one end and out. You know, roaches go in and into a Fox. The roaches hit the wall. They bounce off the piston baffle.
The restriction in this thing is that Venturi, which is tiny.
Yeah.
Okay. That may be. I'm guessing that's.
Measure it. You got your caliber. I never even measured mine.
It's not a quarter of an inch. I think that's 215, 220.
220.
We shall see what my
let's see.
How close
expert
my eyes,
calipers here.
How close my eyes are to my caliper.
That's what he said. 292.
Well, I'm getting. Boy.
Fools you, doesn't it?
I'm getting 280, which is about what I would figure on for a 40 with a spray
That's what
bar.
Tiger 46 is.
Yeah.
You know, I think from watching these things fly, and I've watched 6 or 7 of them, I think it wants just a skosh bigger Venturi so it'll use more fuel when you got it squoze.
Yeah.
Well, making Venturis up is
he was grousing about
no big deal.
It is to get 2, you know, when you get down to 2 ounces a run. If you open the Venturi up, it's going to gobble more fuel and
but the runtime is the runtime's going to get more consistent.
Yeah.
Yeah, that'll work. I
just
agree
like
with that.
going up in nitro, the same thing.
Yeah, same deal. Yeah.
You get 3 clicks instead of 2.
Yep.
Well, I just again, that's you know, I
well, you've run more of these than I have. See,
Yeah,
you have the edge on
McGregor-
figuring it out.
Don McGregor's had real good experience. He was the only one who just said, "Oh, okay, I'll drill a hole. I'll make that bigger."
Yeah, he ran. I said, "How big did you make it?" He said, 2 drill. I said, "What do you mean? What's the 2? I mean, an inch and a half." He didn't know. He just said it's bigger.
He's got a number drill.
Okay, he had a set.
Yeah. Wendy, we talked a minute ago. I don't know if it was on the tape or not about cutting a heat dam in this head.
Right.
Do you want to do that? My thought on this thing is I want to aim this at somebody who is the proverbial farmer in South Dakota, has no experience, no measuring tools, no machine shop. He's got to be able to do this with stuff on his kitchen table with a pair
I'd like to do
gas pliers, and away he goes.
Next time you're here is I'll get a roll of film, and we can write a little blurb for Stunt News. The low budget K&B rework.
Yeah. Okay.
Consists of. Now, in an all perfect world, you could make a pattern for this.
Yeah.
And I mean, a rough drawing.
Yeah.
And
Yeah.
And that would be like the low budget rework for somebody that wanted to try this.
Right.
But with no casting, no foundry work,
With
no
don't need a machine
Let's
shop.
see how that works before you do any, even go to the cutting the head. Maybe that's
Yeah.
the whole. See, if you don't know which it is,
Right.
if you do
That's-
3 things,
that's-
which one made the engine run
Right.
better?
That's what I'm wondering, if maybe we don't want to take our time here.
I know that
do
thing in
one
a.
step at a time.
I know that thing that I've heard about. I've asked several people had that work. Great. Okay. Can't be a coincidence if 4 people tell you that.
Yeah.
Kenny even told me about somebody was doing that at the club. I don't even know who. I said, well, who did it?
Yeah.
You know who would probably know? Guy with the old time stunt guy.
Doug Benedetti?
Benedetti knows
Yeah.
all these
Well,
little. These, yeah.
there's a story.
I mean, interesting stuff that.
Doug only runs 4-bolt Foxes.
Right.
Okay.
Right.
In those
He probably has more than Fox has.
in
right
those
now.
silk jobs.
Yeah, they're
that,
beautiful.
That we'd give our arms for, and
Yeah.
maybe our eyes.
If
too.
he dies at the field, there'll be a herd of people running to get him in their van.
The reason he runs 4-bolt Foxes, and you can see this from outside the motors. You pick up a 4-bolt, pick up a
Yep.
6-bolt in your hand. Gee whiz, the 4-bolt has this little, small, straight-sided bypass,
Right.
about 3/32 of an inch deep.
And they opened it up
The
on the
6
6-bolt to get
They
more
opened
power.
it up. They made it when you side mount it and you turn it in an outside turn, it goes
Blup.
because you just filled it up with
Yeah.
liquid fuel, put the fire out.
I agree with you guys, except I think low budget hot fix to make this a more trackable, serviceable motor would have been to put the Venturi on it first before you take it apart. Randy Smith won't let me own tools to take a motor apart.
You're that good, huh?
That's good. Don't if you ever have a problem, send it
back. Don't tear it apart.
Right.
Don't try to figure it out.
Needle valve. He lets me put needle valves in them. All by myself.
Jimmy, the true story, Jimmy one day couldn't get the Venturi out of a motor that was in a plane.
Right.
He wanted to get it out without taking the motor out of the plane, and he had vice grips. Well, by the end of the day, I don't think air would have gone through the Venturi. And he was determined not to take those 4 bolts out. He was going to pull it and yank on it. We were all holding the plane, and it was egg-shaped, it was cone-shaped, and there was no needle valve, and it wouldn't come out.
And it wouldn't budge.
He distorted. I mean, it was an egg.
Well, it's a 4-letter word. It's a 4-letter word, but heat.
Heat.
Heat is the key. If you have to,
Yeah.
take the whole engine, mount it up in the block,
Yeah.
clamp everything down, heat it good, and then get yourself an eyedropper or so with ice water in it. Drop the ice water
In the
on the
Venturi.
Venturi,
The Venturi will shrink. The engine's still hot.
walk right
Boom.
out. Nothing.
By the way, this is one thing I like about
When
this
was the
engine.
last time you had a new muffler put on your car and the guy at the lift
Couldn't get the old
didn't
one
have
off.
a torch to work with?
Yeah.
Didn't have a torch when he put the new one together. Heat it up, Willie.
Yeah.
It's not red. Heat it up some more.
Propane. Right.
And they stick it together.
This is neat. How this crankshaft, the threaded part comes out. If you ever, land on concrete
Yes.
and bend it, you don't bend the crankshaft. That's
Yeah,
a really nice feature.
That's a stud crankshaft.
I like that.
Well, the stud is bottomed in there, but that's true. If you bang up this stud,
You just replace.
you don't have to buy a shaft. You grab this in a vise carefully and walk it out with a
Right,
pair of vice
right.
grips. Buy a new stud at the auto parts store or at the hobby shop. Take your pick. 1/4 thread it in, and bingo.
That's a nice
And
feature.
then you could use that for piston stop.
Piston stopper, yeah. Rich is dying to buy a piston stopper
Why
tonight.
is he hung on piston stops?
Piston stop.
You're being very...
Now, phase 1 of this test is now complete. The motor's put back together and it's back in the plane. What this has transpired is we have the JB weld in the transfer port that Tom did on the beginning of this video. We've also done on another tape, we've done a lot of experimenting with a longer Venturi. It's much longer, in fact, and a different base shape that would tend to soften the engine characteristics that Bill Mazzoni made up. Now, the Venturis are available from Bill Mazzoni. Needless to say, the motors are available from John Brodak and Tom Hampshire. You've got to call him and figure out what he did, or watch the video and do it yourself. Anyway, it's a very inexpensive thing to do, and we've gotten as much as we could squeeze possibly out of a totally stock motor. But now that we have one with little modifications, we can sort through and we can find out which modifications seem worthwhile doing, and the Venturi is totally worthwhile doing. Totally worth the effort and time that it takes to do it. The round tongue muffler that we got from Big Art with the holes opened up to 120 seems just beautiful. The one thing I haven't done, and it's my own fault, I haven't gotten a pressure fitting so I can run uniflow or no uniflow. We've just been running a wide open tank, so I don't know. It looks like it's going to rain any minute, and the air certainly looks bad, but I'd like to get a couple of flights on this setup if I possibly can before the rain comes. Now, in the last couple of days, I feel like we've really made some gains with this. We've really made some gains in that with the K and B part of this program. And again, it's a two-prong approach. We're trying to do this from two separate angles. But so far, this is really working better than I really ever expected. And it's very, very easy to do yourself. A Venturi, some JB Weld. These are not high-tech things that you need to be afraid of. But again, the more flights I can get on this now, the more I'll be able to go into the next part of the program knowing how well each one of these things has worked. A couple of the significant gains came from opening up these holes to 120. Biggest one, the length of the Venturi, and we will be testing even longer ones soon. In fact, I'm going to be involved in testing some longer ones with Don McGregor. He wants to make some up. He makes his own stuff. He wants to make some up for some of the other engines that he's had these similar idiosyncrasies with. So we're looking forward to maybe even doing a little thing for Stunt News on how this is working out. But basically, thanks to Bill Mazzoni, thanks to Tom Hampshire, thanks to all the people that are freely contributing their time to this program. Well, it'll be interesting to see just how many of these things ultimately are going to pan out that we can use them on other motor setups too. The first thing that comes to mind is Max FPs would be a good candidate to try some of this stuff on. And I wonder if Tom probably has already tried it. Some of the smaller motors where you block up that big transfer port, make a big long Venturi, get a restrictive tongue muffler. I think there's a lot of performance gains in here that are really low money. Low money to do this. Again, it's starting to look like, because of the way the air is today, it gets a little risky flying in the coffin corner there, but I like to be able to go home and look at the videos, and when I look at the videos, I like to hear that motor. I always try to wait till the other circle is done with their flying. So in the background, I don't hear any background noise. I can just listen to my own motor run. I'll wait for him to finish. The way the trees are looking back there, this may just be a throwaway flight, but we're at the end of a really good productive day here, so kind of nice to know that the time we spent doing this has not been wasted.
The guy that writes the engines thing?
Bill Mazzoni made these Venturis up now. I only have one, or I'd give you one to try.
That's all right.
You could ask Bill Mazzoni, you know, he's in Tampa, just,
Well, now what? But that,
See, he made it
on
what?
a standard. That's on a standard William port, right?
but where it enters the engine, it's flat, it's not tapered. It's totally different than the one that comes with the motor. The one that comes with the motor has a taper going in at the motor.
Yeah, I read one out.
And you want to do the other thing, you want to make it smaller, not really out. But anyway, this one, today I've been amazed how well it's worked.
Is this what thing he bought?
No, I just put that on there.
Where's the metal go? Up to there?
Right to the end, yeah. You can feel with your finger.
Oh, it goes almost to the mesh.
Yeah. He made this 280. It really should probably be like 270, but put while I'm ahead here. It's running fine today. I had a lot of good flights with it so far.
Does he have them for sale?
Yeah, you just call him up. Tell him you want the same one Wendy has.
Yeah,
They'll probably charge you $1,000. He knows you got a lot of money.
he knows I'm loaded.
You're loaded, but not with money.
Retired loaded.
So how's the new plane working, okay?
I think it's going pretty good.
I'll come over later and get some film of it.
I'm
It
gonna
looked
go.
pretty good from over here.
It pulls like a maniac.
Take some tip weight out.
I put some tip weight in. I didn't think I hit enough because it was trying to come in at me. So I put a half an ounce.
The air is rough today.
Well, the air's getting rough right now.
Now, it's been rough for the last hour.
But it's got that engine and the wings.
This is 62 ounces?
62 ounces.
And what design is it?
That plane is
A kit?
No, that's Dixon's Praxis.
A Praxis, okay.
Only I made an upright engine.
Yeah, well, that doesn't make any difference.
No, he made it. You know the one he copied off that Japanese guy?
Yeah,
Kim Komodo or something?
Yeah, Godzilla Komodo or whatever.
Yeah, whatever. And he made a side-mounted engine. So yeah, I didn't like it.
Yeah, I'll come over later and take a look at it.
I'm gonna go. I gotta go home.
No, an adventure a minute here at the club field. End of every day like this, I try to evaluate in my own mind exactly what, if any, the gain was, so I can be sure to document it somewhere on the tape. And I think before I even go any further, really want to do some more testing with longer Venturis on these motors, on Schnurly motors. I'm not so sure it would be a big gain on a Fox 35, say. It would be the opposite, but in these motors that are basically geared to make a lot of horsepower, having that long Venturi, at least on this one, boy, seemed like a major gain. And I hope Bill Mazzoni is going to go run, when he watches this, he's going to run right to the lathe and make me one. Hey, we actually could make it a good half-inch longer. And don't make it 280, make it 270 or something like that. A little bit smaller wouldn't hurt. Anyway, I always like to look the plane over. This plane is holding up real well for a plane that's taken a lot of abuse. The tank is totally clean after a couple days of flying. In fact, I've done away with the filter. I don't even have a filter in the system anymore. And it doesn't seem like there's a lot of times it doesn't even, you think, oh, I spent all that time and then you just put a motor in a plane and go fly it. Well, if you're chasing more performance, that's not really the best way to do it. Any kind of tuning thing just takes a lot of work. And this, so far, this has been working well. I really have to say, this has been a very pleasant surprise how easy it's been to get this to work. And if you go back to the earlier videos when we had those relatively fast flights and Kyle was flying it and Joe had a Musco and whatever, and then you look at you compare it flight for flight for what we have now with the work Tom's done and the Mazzoni Venturi, it's a whole different ball game. Now we're at the end of this tape, but we're going to be trying this, I hope, in the real near future. This is, whoa! This is a part that Bill Mazzoni sent me. What it is it's a modified head. They call this a button head in the world of speed, but it's a head with a 7.5 to 1 compression ratio for the K and B 40s that John Brodak is selling. We're going to be testing this soon. The only problem is we've run into the same problem we always run into. There's so many things going on here at once. We really don't have time to do these individual tests every day of the week. We try to keep up with them. This is one of the things that we really want to get into. Also, coming up real soon on a set of tapes we expect within the next week or so, we've been speaking to George Aldrich on the phone. And we're going to be getting one of his Jet 50s to test out, do a little bit of prop testing on, maybe even get it retrofit in one of the planes. So I know people always have an interest in motor work, motor retrofitting, those kind of things, and that's one of the things we look forward to. So stay tuned, we'll see you on the next tape, and we're just looking forward to a whole bunch of exciting things going to be happening around here real soon. And special thanks to Bill Mazzoni for the Venturis. Special thanks to Tom Hampshire, all his time and energy. And we're going to be doing some more prop work with the Brodak dope. It's all coming. And Wendy, don't forget, you gotta finish that I-beam Spitfire soon. Hey, boy, when the season of mowing grass and chasing tenants around with a rake ends, I'll be glad to. And I gotta go check on my frogs out in the pond. I got froggies out there. Hey, thanks for joining us. I thought this would be an appropriate picture, being we're going to have Todd Lee on tape here pretty soon. Hey Todd, I got to tell you, your old man is a cool guy. I don't care what you say about him when we're out having pizza. Looking back, boy, I'll tell you, can you ever forget Billy Suarez's jet? Oh man. Think of some of the cool things we've had in our life. Hey, 1985 concourse winner. A lot of cool things. Hey, speaking of cool, Bob Gildini's Stingray. And I hope, Bob, hey, if you hear me, please, let's get that World Championship going out there. Two of the nicest guys in the world to stunt. And we affectionately call him Big Ted and Little Ted, but I think he's Big Ted now and he's Little Ted. I don't know. And he's making his planes lighter than his. Maybe Big Ted and Little Ted are reverse Little Ted now. I don't know. It's all done with tongue-in-cheek. Have a ball. All the people that are busy building Cardinal kits. All the people that are waiting for me to finish this I-beam Spitfire. All the people that think the canopy is on crooked, hey. All the people that don't know a canopy from a tail hook. And Billy Simons, we still love you even though you moved to Florida. The world's most exotic tail hook. I'm telling you, it's been a great year. People laugh all the way to the bank. Laugh all the way to Brodax. Anyway, we will be seeing you on the next tape. Thanks for joining us. And keep those motors humming. No matter what Tom Hampshire says, keep them humming. Tell me that's not ugly. Don't you wish nobody ever took this picture? Put the tongue in the mouth, Artnowski. Hey, see you on the next tape.